Hi, I'm PAKEEZA BaTOol and I'm here to teach the AP Chemistry. Today, we're going to discuss the AP Chemistry syllabus and then some selective topic for them. Here we have almost 9 units in AP Chemistry. The unit 1 is basically atomic structure and the properties, and the unit second is compound and structure and properties. Unit 3 is properties of substances and mixtures. Unit 4 is chemical reactions, kinetics, thermodynamics, equilibrium, acid bases, and the last one is thermodynamics and electrochemistry. You can see here we have basically the exam weightage for these units. For the section 1 of the paper, that is multiple choice question. Okay, and you can see for the first unit we have a 7 to 9% of weightage for the multiple choice section, and same for the unit 2. But you can see here the third unit having almost 18 to 22% of the weightage for the exam for the multiple choice section, and we will discuss why this unit having the most of the weightage of all the exam section. And the next is basically the chapter 8 having acid and bases having the weightage 11 to 15% for the MCQs. You can say multiple choice section in exams. So let's discuss one by one that what are the details topic we will discuss in these topics in these units or chapters. The unit 1 is atomic structure and the properties. In this unit, we will discuss atomic theory, that that how atom exist and which are the theories represented by different scientists. And then we have atomic models, that is Bohr atomic model, quantum mechanical model, and then this is one the important thing, the periodic trends, that ionization energy, atomic radius, and the electronegativity. You can see the ionization energy and electron affinity as well. We will discuss all these trends and how ionization energy increases or decreases from top to bottom in the periodic table, and how it decreases from left to right in the periods. And the next unit is a molecular and ionic compound structure and the properties. In this unit, we will discuss the chemical bonding and the covalent ionic and metallic bonds and the Lewis structures, and the main thing is the whispers theory, that is valence shell electron pair repulsion theory, that is whisper theory. This is a very important topic in this unit. And the next one is the quantities of the matter and the stoichiometry. I have told you that the unit 3 having the most of the weightage. Why? Because this unit includes the topic that is stoichiometry, and stoichiometry is having some calculations, so that's why this is very important for the MCQs, so you can say multiple choice question point of view. So that's why this unit having the most of the weightage for the multiple choice section of the AP chemistry paper. And the next one is the limiting reagents and the percentages. All these MCQs are taken from this part of the syllabus. Next one is the chemical reaction. The unit chemical reaction will discuss the types of reactions like combustion, precipitation reaction, acid-base reaction, the rocks reaction, you can say oxidation reaction, basically, and how we balance the chemical reactions and so on. This is all another important topics that I highlight here. And the next topic, the next unit is basically chemical kinetics. In this unit, we will discuss the rate laws, rate of reactions, and the factors that affect the rate of reactions, and the Arrhenius equation and activation energy. We know that the activation energy and Arrhenius equations basically tell us that how increase in temperature affect the activation energy and catalyst and all these things and chemical reactions. And the next one is thermodynamics. In thermodynamics, we will discuss the heat, work, internal energy, and the first law of thermodynamics. And the Hess's law, this is very important for the chemistry point of view. Electrochemistry in chemistry, thermochemistry in chemistry, we will discuss the Hess's law. Okay. The next one is chemical equilibrium. In this unit, we will discuss the Lee-Chatelier principle. This is very important, and the factor affecting the equilibrium concentrations and the equilibrium constant K. The second last unit is the acid bases. In this chapter, we'll discuss the different concept of the acid bases given by different scientists, like Lori Bronson concept and Lewis concept and Arrhenius concept, and the other one, the which are the strong bases and which are the weak bases and vice versa. And the pH and pUH and before solution, all these fall under the category of acid and bases. And the next and the last one, the chapter 9, the application of thermodynamics. In this unit, we will discuss the second law of thermodynamics, gives free energy and spontaneous and non-spontaneous reaction and so on. This is all about the AP chemistry syllabus and units and their weightage for the multiple choice questions. And we have discussed now the first part of the AP chemistry exam, that is multiple choice question. But what about the second part, that is the free response? It also contains 50% of the total score. It contains basically the long questions, and you can see having 10 points each, and the four short question having 4 points each. In this way, we have basically 105 minutes for these exams, and this is all about the AP chemistry exam. So let's discuss the topic, that is the redox reaction from the unit 4, oxidation reduction. So let's jump towards that. The redox reactions, basically you can see from the word redox, mean RED represent the reduction and OX mean oxidation. Redox reaction means reduction oxidation reaction. So what are the reduction and oxidation, you can say redox reactions? The redox reactions are basically the chemical reaction that involves oxidation reduction. These are two reactions that combine to form the, uh, you know, we can say combinedly that redox reactions. And the oxidation reduction reactions occur in nature in so many ways, and that basically the what is the oxidation? Oxidation is basically loss of electrons. Okay, whenever there's oxidation occur in any substance, then there is basically loss of electron in that substance. And whenever we discuss the reduction is basically the acceptance of electrons for other substance. Any substance when accept electrons, the, basically there is occur reduction. There is reduction occur. And in this way, the redox section we combine talk about, if we combinedly talk about them like oxidation reduction and like redox reaction, they are basically the reactions in which electrons are transferred from one reactor into another. Why? Because one from one substance the electron being loosed and you can lose, and the other substance the electrons are being accepted. So in this way, there is transfer of electron from one reactor to another. And there's so many very examples of rock reaction in various environments like photosynthesis, okay, respiration, combustion of coal, and the production of and use of fertilizer in our nature. This is all about the examples of the redox reactions. So when the electrons are transferred, the redox reactions occur. Okay, we got that. But what are the details of this reaction? Let's jump towards the details of this redox, means oxidation reduction reactions. We know that the oxidation is the loss of electron from an atom, molecule, or ion. On the other hand, the reduction is the gain of electrons from an atom or molecule or ion. So we can say that the oxidation and reduction occurs simultaneously, like in a chemical reaction. If one side of the chemical reaction, the oxidation occurs simultaneously, the reduction occurs side by side. So we can say that the oxidation and reduction occurs side by side. And keep in mind, whenever there's oxidation, there's increase in oxidation state. Oxidation state. What is oxidation state? Oxidation state is basically the charge, the valency of on any ion. Let's suppose we have iron having a +2 charge. Okay, this is oxidation state. Iron having a 3 charge. This is oxidation state of iron. Let's suppose iron in free oxidation state, like in zero oxidation. These are basically example of the oxidation states of metals and non-metals. You can write them like oxygen having oxidation state 2 negative. This is for the non-metal. This is basically oxidation state. So whenever there is increase in oxidation state in a chemical reaction from one atom to another, this is oxidation. And when there is a decrease in oxidation state from one atom to another atom in the chemical reaction, there will be reduction. We will discuss in some example, but like in this way. We have a given reaction like a copper and magnesium. Copper ion and magnesium metal when react together, what happened? The copper 2 plus change into zero oxidation state. I have already told you that when there is increase in oxidation state, there is oxidation, and when there is decrease in oxidation state, there is reduction. So let's see what happened here. We have a chart, we have a scale here that we have a zero value, and when we go down from the zero value we have a negative number like minus 1, minus 2, minus 3, minus 4. And whenever we go up from zero value we have a positive 1, positive 2, positive 3, and positive 4 value in mathematics. So you can see here that here the copper have plus 2 charge, plus 2 plus oxidation state. Okay, but here the copper having zero oxidation state. So you can see here that we jump from positive 2 to 0. It's mean we go down, or you can say the oxidation state decreases. So when the oxidation state decreases, what happened? There is reduction. There is reduction. So you can see here the reduction occur here. The change of copper 2 positive into copper 0 is reduction. And we have discussed the increase in oxidation state is oxidation. So you can see here we have magnesium in 0 oxidation state, okay, and it changes to positive 2. So it's mean we have reverse case like here that we move from 0 to positive 2. It's mean we jump upside. There's increase in oxidation state. There is increase in oxidation state, that is oxidation. Clear? So here we have oxidation of magnesium 0 to magnesium 2. This is basically all about the oxidation reduction. If we got this concept firmly, then we can solve any equation, any question related to oxidation reduction, and where there is oxidation occur and where there is reduction occur. So this is all about the oxidation and reduction. And now we can also find out how there is oxidation and reduction in these examples as well. But at this time we're discussing some other terms like reducing agent and oxidizing agent. Keep in mind the agent having a name, some name. Of course, the agent is responsible for doing the work which is assigned to him, the name assigned to it, or you can say. So it's mean agent name is reducing agent. It's mean agent has to reduce others. Reduce others. It's mean reducing agent reduce others, but itself it get oxidized. So can I say that the reducing agent is substance that can reduce others but can be reduced itself by losing some of electrons, and vice versa for the oxidizing agent. The, here the agent name having oxidizing, it means it has to oxidize other and reduce itself. Okay, so it's mean jump towards reducing agent again. Reducing agent substance which reduce others but oxidize itself. It's mean here oxidation occur and oxidation state increases, and it acts as electron donor because it's losing the electron. Here the oxidation occur. Okay, oxidation is occur here. The substance which act as a reducing agent will reduce others but oxidize itself. Okay, oxidize itself. But in that case, the oxidizing agent oxidize other but reduce itself. It means it will gain electron. Reducing agent lose electrons and oxidizing agent as reduce itself, so that's why it will receive or gain electrons. Okay, let's summarize. Reducing agent is the agent that reduce other but oxidize itself. Oxidizing agent oxidize other but reduce itself. So here it oxidize itself, it means there occur oxidation, and in oxidation there is increase in oxidation state, and there is a loss of electron. And in the other case, we have oxidizing agent that oxidize other but reduce itself. So it means their oxidation state decreases and the reduction reaction occur, and there will be a gain of electron. Clear? So you can see in this diagram, like suppose we have here two reactants and two products. Okay, let's suppose here I have copper oxide and hydrogen combined from copper and water. What happened? The copper oxide acts as an oxidizing agent, will oxidize other but reduce itself. But the copper, but the hydrogen here act as a reducing agent. It will reduce others but get oxidized itself. How? Because you can say copper oxide having oxygen, so that's why it as oxidizing agent. It will give this oxygen to hydrogen and oxidize itself. It's H2. It will form H2O. And H2 here act as a reducing agent, mean it will reduce other but get itself oxidized. We can say H2 converted into H2O. Its mean oxygen is added into H2. Its mean H2 get oxidized itself. So this is how in a chemical reaction, the oxidation reaction side by side, and one reactant act as a reducing agent and the other one is act as a oxidizing agent. So this is all about the redox reactions.